So hello again. So we'll concentrate this time on a customer case. One is about a French customer that is INRA, not very far from here, and the other one is an American case. The first one is in genomics, and the second one is in IoT, in a mining machine. And so I will present together with Fabien, that just arrived, and Tobias. Tobias is working with ActiveEon and is originally from Germany. So just to give you a little bit more detail about the technology, what makes it very usable in industrial environment is the fact that we are interfaced and we deal with many different external software, so like external scheduler or ETL. So in the UK, for instance, we work with Talend on a big project for data transformation for visa delivery. And at the level of orchestration, so the company motto is accelerate, automate, and scale. So these are two use cases that we'll present where automation is very important. We are helping our customer to automate their IT. For instance, it means that when they do that with mining machines, sometimes there is a new mining machine to add into the processing of data, and this is automated, or to remove a machine from the mining machine. And what we more and more see is that the automation goes all the way to fault management. Even if we are in the cloud with virtual machine, with nice things like Docker and Kubernetes and things like that, those machines fail sometime, or you have IT processes that fail. And part of the automation is to manage failure and to manage recovery in some fully automated or semi-automated manner. And this is, of course, very important because even if we are in DevOps, you still have a lot of people that develop software and hands on the software to people that are in operation with not very high IT skills, actually. Okay, so we'll cover that before, and the two use cases that we'll present you. This is Joy Global here and INRA in biotech. Okay, so I will let Fabien, that actually worked with the customer, present the INRA case.
So the use case we implement at INRA was basically a collaborative development and simulation environment based on the AIR language. So we deployed the ProActive scheduler on the INRA infrastructure, which is a cluster of about 25 machines. And the INRA scientists are able to submit directly some AIR computations. So R is a reference language for statistical computations. So they are able to submit directly from the R environment interface to the ProActive scheduler, and this will transparently be executed on the cluster. So which means that a small instance of R computation will be run on individual machines, and our connector toolbox will aggregate those massively parallel computation in a single view. That's about it for our use case. So another part of the use case. So that was a collaborative R environment project, and the second use case was actually analysis of sequencing data. So that means that so basically every week a sequencer is computing DNA sequences on genomes, and on various kind of products or cells, and produce all this sequencing data as a large set of files. And the scheduler is then used to dynamically grab all the files produced by the sequencer, and then running on the INRA cluster a set of typical DNA processing, which is DNA alignment, well, I don't know all of them. I'm not a DNA scientist, metagenomics scientist. And so we use basically our scheduler. This example is a real production deployment, and the other project is a collaborative environment. So we have two schedulers for two different uses. So in terms of architecture, what we call here the ProActive Parallel Scientific Toolbox, this is our environment. This connects to the ProActive scheduler. The ProActive scheduler will then execute our computation on the Linux cluster here. Regarding the DNA sequencing production environment, this comes from the sequencing here, and dynamically when new sequencing arrives, we integrate this information into the ProActive scheduler, which will execute post-processing on this Windows cluster. Any question regarding? No? Okay.
Hello. I'd like to introduce you to our use case of IoT. We did this with Joy Global, and I had the pleasure to work with Joy Global. And as you see, Joy Global, they manufacture and service this huge machine for minings all over the world. I was super excited working with them. They explained me all those things, how it works and how it goes in the mines. And yes, as you can see, they have they operate mines underneath the earth. So there's machines underneath the earth, completely isolated from the internet, from anything. And then they have mining machines, in the outside. And so they maintain all those machines. And Joy Global, it is a global company, and it's a Fortune 1000 company, and they have a revenue of 4.4 billion a year. And the first thing we did, we identified their needs. We had a very iterative process, working very well, very close with their team, and there we found that we just discovered their needs. And they needed unique analytics for each types of machines. Like you saw those pictures there, and you can guess that each machine needs different analytics. So, and they have many types of machines, many groups of machines, and they wanted to see groups like this machine has a tire, so you need to check the tire pressure, for example. So this is a group, and there are different types. Different types can be in different groups, and vice versa, just complex dependencies. So and they wanted to trigger analytics on specific events, and we created this beautiful solution for them. We have a very flexible solution for them, and we have a REST interface, and this REST interface were easily combinable with other solutions they had, and we could do unique development for them, and they could connect their unique development with our solution. And we were able to automate the whole processes in the data center. And the most important things are we have fault tolerance for each application. What you can guess when you don't have internet in a machine and something doesn't work, then you need some fault tolerance. We can virtualize resources, and we have fault tolerance for them as well. And we have whole fault tolerance for all subsystems, for sub-distributed systems. And here I like to show you the architecture what we have. You see the data coming from all the machines, and then the data is processed with our software. And our software, we orchestrate Python, Java, MATLAB, different types of analytics, different types of codes. And it's dependent on each machine, each group. So it's a huge complex software. But with our interfaces, with our workflows, we can cut this into small pieces that people can comprehend it, and people without computer knowledge can understand it and modify it actually. And then what comes out is real-time control and optimizations. So you can see how your machines perform and how what's going wrong, what's going good with your machines. And you can also see this as a non-IT guy. So people working on the machines have access to this data as well. And we can scale this. So we run this on Amazon. So you want to do this?
Yeah, so just to briefly conclude, first for the case of the mining machines, the Joe Global, there's something interesting. This company, this billion-dollar company, used to sell the machine. Now they do not sell the machine; they sell hours of operation of the machine. The same way that Snecma Motors used to sell engine for plane, now they sell hours of engine. And so those companies are getting in the strongest need to optimize all their IT in regard to the operation of those industrial processes. Okay. And so in both cases, we accelerated treatment with terabytes of big data. It's interfaced with analytics. So they use R in the case of genomics. They use MATLAB in several of our customer cases. You can use Python, new Python, or proprietary software like SAS. And in many cases, it's a case for the mining machine. They use both on-prem infrastructure and in the cloud. And we must say that most of our cloud clients are on AWS today. Okay. And finally, it's fully open source and they benefit from it. Thanks very much for your attention.